Yes.
Yes. Yes, please. Call this question fast. Surface tension of the liquid. A ring. Ring on the water. So assuming that this is water, this is the surface of water, and now you will see a ring here. Correct? You will see a ring. Okay? Now you are trying to lift it up. So the surface tension of the liquid. And the radius of the ring is radius per meter, and is lifted from the surface of 4 meters. So you are applying a total force of 4 meters. Okay, all these forces put together is 4 meters. Up. Okay, then they are asking the surface tension. Well, the basic formula you have got to use. You should not take so much time. Prabhus and Aditis and Anushris and all you people, Namans and all, everybody there, try to answer. These are all simple questions. The basic formula you use, you will get it. Why you are taking so much time for this? See, the force is what? The total force acting. See, the forces, what are the... See, the same diagram as we have seen earlier, a needle being lifted up. Same thing. Okay, only thing is here, you have got the surface tension T and T into the line along which the surface tension is acting into 2 pi r. Okay, but there are two. See, when you have a ring, you have one surface here and one surface here, just like the needle. So therefore, you have to multiply it by 2. So this will be equal to the total force, the total surface tension force, and that they have told is equal to 4 newtons. So you cancel this, and this R is equal to 1. Therefore, the surface tension is 1 by, right? Newtons. Newton per.
Sir, here there will force applied because of the weight also.
Pardon? Yes, that's a good question. It is lifted from the lifted surface by a force. That means now this 4 Newton force is in excess of mg. This 4 Newton force is in excess of mg. That's how you have to interpret. There is no other way to interpret this. Otherwise, you cannot get lifted. Or else they should have given the mass of the ring and all things. Okay, shall I proceed, students?
One more note, sir.
Yes, please.
Sir, why they have mentioned that liquid film remains in?
Why they have told is because that means the ring is just above the liquid. That is, the liquid is still adhering to it. It is not left.
Okay,
that is that. Otherwise, you will not get this contour. You will not get that contour unless you specify this. If it is fully floating, then the tension forces will be like this. Just now we discussed. If it is just coming out, the tension forces will be like this. Got it? Just for that. Great. See, I am again appreciating this boy because he is very, very sensitive and he quickly asks a question wherever he has doubt and is a very keen observer. He is not seeing. Okay, please. I will keep telling this again and again because I want everybody to develop this attitude, and with this attitude only you can learn science, and if you learn science only you can crack the examinations and you can be successful in life in the field of science if you choose. Otherwise there is no shortcut method here. The radius of the soap bubble R, the surface of the soap. Right. If you use the basic formula, you should be able to get this. So they are asking you
Yes,
to
sir.
link up the radius, surface tension, so forth. Okay, so in those of you who are still struggling what to do, you draw the diagram. You draw the diagram of a soap bubble. Okay, and then its radius is R. Okay, and the surface tension is T, keeping the temperature constant, right? Okay, you know there is no exchange of energy. Thus the radius of the soap bubble is doubled. Okay, so one more diagram like this radius. Okay, that means now you see the surface area is increased. The surface area is increased because the radius is now the new radius is 2R. Okay, well, so there is something like energy and all. There is only one formula for this. F by N is equal to S by P. Hello? Correct?
Yes, sir.
So in this case, you have the surface energy for this one, which we call it as surface number 1, and this surface number 2, and the surface area is A1, and for the next one, surface energy becomes S2, and the area is A1. That's it.
So we should consider the surface inside and outside.
See, it's a bubble. It's a very thin bubble. No? It's a thin bubble. No? Bubble, the thickness you have to, it is almost negligible. So the inner area and the outer area are equal.
Equal, sir, but we have to consider both.
You have to consider both. Definitely, you have to consider. As far as the surface tension is concerned, you have to consider both of them.
Yes.
Okay. So the energy necessary for this means what? You have to find out S2 minus S1. Correct?
Yes, sir.
You have to find out S2 minus S1. Let's do this. Why should it be difficult?
Yes, sir.
So what is the answer? What is the answer?
So I got option, please.
Why don't you tell it loudly? You got option A. Somebody else got some other option?
Yes, A.
You also got A. 2 students got A, others are still struggling. Come on, friends, this is the sphere. It's simply a sphere. So just find out yes or no. What is S1? 4 pi r square into T. And what is S2?
Into 2 hours.
Into 2. And this will be 4 pi 2r square T into 2. So S2 minus S1. So this is going to be additional 2 to the 4, isn't it? So this is going to be, hello, so this is going to be 2t, that is 8 pi t r square, and this is going to be what? 2 to the 4, 4 4 the 16.
32.
32 pi t r square. So S2 minus S1 will give you 24 pi t r square. Simple. A plus B is equal to C. So this is the right option. What is so difficult in this? Why so many students have not solved? I don't know. Okay. Shall I proceed, students?
Yes. Yes.
You want to ask any question, you can ask. This is a very standard problem. I think everybody should solve this. So one liquid drop of diameter D breaks into tiny drops. So whatever they have said, put it with a big liquid of diameter D. Well, this is split into small droplets of 27 droplets. So what happens here? The volume is the same. So volume of this, so if you take the diameter of this is small d and the diameter of this is d. So 4 by 3 pi d square, pi d cube. Volume of this must be equal to, this is split into n drops. N into 4 by 3 pi d cube.
And that is diameter.
Tell your diameter, no?
Yes, sir.
Then diameter means you take it by 2,
By
isn't it?
8, sir.
2 cube diameter.
Yes.
So this will get cancelled. Okay, and this will also get cancelled. So you have this standard, this one, that is capital D cube is equal to n into small d. Okay, so this will be the basis for the next this one. So you have found out this relation between the two, and then
Yes, sir.
the resultant change in the energy. So same thing like what we did just now, the same thing you have to do here. So we just now did this, isn't it? Change in the resultant change in the energies, that is say S2 minus S1. Right? Just now we did this. Okay, so for S2 here you have to take this diameter is small d. Hello? Isn't it? Diameter is small d. So if you remember it, it is going to be T. T is common here for S2. T into the surface area. Surface area for S2 will be 4 pi d by 2 square into n. This is S2,
First.
surface area. And S1 is T into 4 pi into d by 2. So for capital D, substitute this n d cube. For capital D, substitute this n d cube. So here you can take 4 pi t by 4. This 2 2s are 4. This is common. You can pull it out. So here in the first case you are going to get here what? N d square minus just the d square. Correct? Hello? Okay, this force will cancel, pi and d will seems to be there. Now substitute the again. For d you have to substitute d. So d is equal to root n d cube. So this becomes pi t into again here n d square minus capital D will be n raised to 1 by 2 into small d. Correct? Hello? But n is also going to get multiplied, so you have to write here 2 by 2.
We have to find in terms of capital leases so we can directly.
You have to find in terms of capital D only, because the answer is given. Sorry, I should have written it the other way. I should have written it the other way. I should have substituted for this one. Anyway, I am going ahead because again I have to rub it and do that. Okay, so here pi t d square. Thank you. I should have been considered careful. So n minus n raised to 2 by 3. You'll have to do. Okay, it will become a bit difficult. So if you had taken it in d square, I think you would have got the answer in one shot.
Substitute the value of answer, that is 27. So
27. So 27 if you substitute also, we can make it here. So 27 minus, this is 1 by 3 of 27 will be 3. 3 3 is a 9. Isn't it? So 27 minus 9 is 18. Correct? Hello?
Yes, sir.
18. So 18 pi t d square you get. But the answer is in capital D. So answer is in capital D. I didn't see the options, so I made a mistake. So this small d in terms of capital D will be
D square by n power 2.
yeah d square by n power 2 by 3. N power 2 by 3 will again be 3 is a 9. 9 means just will go 2 will be there. So you get here 2 pi t d square. The answer 2 pi t d square is option. Correct? Okay.
Yes.
I don't why I expect everybody to do this for whatever reasons beyond my comprehension. Many of you are not doing it. Anyways, okay, friends. See, you have to make science look very simple, and science is really interesting, very interesting. And take interest and learn science. And these formulas, these things, they will not appear to be very difficult. Okay, but if you are studying with an intention to pass examination, okay, then you are putting pressure on yourself. Okay, right now it should be pleasure. Exams come at that time, let us face it. But right now, why do you want to create the tension while learning? Please don't do that. This is a very good problem. I hope you know the theory for this. If you don't know the theory for this, then I think I should help you. If you want me to help you with the theory, I will help you. Feel free.
Yes.
What is the option?
A option.
Somebody got A option. Okay. Aryan got A option. What about other students?
So I think option B is okay.
Okay, another student got option B. Right. Any other student? So I think you can see the size of this now. B is the largest, A is the smallest, and C is smaller than B. Correct?
Option A is also.
See, when you do this operation, at that time what happens? Not afterwards. When the stopcocks S1, S2, S3 are opened, just after they are opened, what happens? They are not asking you after indefinite time what happens.
So, but they are given at equilibrium over there.
See, the thing is, first as soon as you open, things start happening and it will reach one equilibrium state. After reaching that equilibrium state, something else will happen. Okay, that's what they are asking. Okay, till it reaches that equilibrium state, what happens? You have to tell. See, what I am trying to tell you is A is the smallest, C is slightly bigger than A, and B is bigger than A and C. Is that it? Okay, now I suppose all of you know the theory for this. That is, if you take a balloon and what is there here? The pressure inside is Pi, the pressure outside is Po, correct? Hello? So you have here Po plus the what? The pressure due to the surface tension. I suppose all of you know this particular thing. That is Pi minus Po will be equal to what here for a balloon? Hello, for a balloon, what is it going to be? 4T by R. Correct? Isn't it? And I suppose all of you know how this derivation has come.
What in 25?
It is a bubble. If it is a water bubble, that is only one surface. There are two surfaces. If it was a drop of water, with the drop of water, then it is Pi minus PO is equal to 2T by R. Okay, it is a drop of water, and you should know how this derivation has come. Okay, then only you can tackle this problem.
Yes, yes.
Right? So this very clearly shows that see, now you have got three balloons, A, and then you have got B, which is slightly bigger, and you have got C. Sorry, I think this is the hierarchy, no? B, C. Correct now? Hello?
No, sir. A, C,
A, C, B. Sorry. So A is the smallest, and then C is bigger than this, and B is much bigger than this. Correct? Hello? No. So this radius is R1, this radius, okay, I'll take it as RA, RC, and RB. And what we know is RA is smaller than RC, RC is smaller than. Correct? Hello. And the medium is same. The medium is, this is air, this is air, this is air. This is the same balloon material. And in the process, the temperature is not changing. Okay. So therefore, the surface tension in all these three will be same. Correct?
Yes, sir.
And for all the three balloons, P0 is also same because it is in the same unit. P0 is also same, so the P0 is also same for clock. Okay. So therefore now the difference in the pressure will be Pi minus PO, and this is inversely proportional to R. Is that clear, students? It is inversely proportional to R. That means now here you see RA is very small. Therefore, RA is very small implies Pi is large. So Pia is larger than PIC. Sorry. Pia is larger than PIC is larger than PIB. Do you agree? See, it's just a logic.
Yes, yes, sir.
Only Adil is telling yes sir, correct. What about others?
Yes, sir. Correct.
See, only Aryan and Adil are responding. Others are not responding. Hello, others.
Yes, sir. Yes, sir.
So this is the thing. That means now you see, as soon as you open the tube, open those S1, S2, S3 in the previous diagram. Okay, in the previous diagram, if you open those things, right? Oh, I can take you there itself. Right? Taking this diagram here, the diagram I have drawn on the other board. Okay, I just drawn on the other board. So here you see Pi is greater than this. Therefore, as soon as you open the walls S1, S3 and S2, keeping S closed, then the air in A will start going towards B and the air from C will start going towards B. Therefore, C and A will start collapsing and the volume of B will start increasing. So, C is the right option. not A and B. Got it?
Yes, sir.
Hello, are you convinced? Hello, everybody there? Ask.
Sir, can we apply the concept of potential energy as the potential energy of the molecule?
Potential energy of the molecule, sir. Which molecule?
Yes, sir, of that bubble.
Bubble? Balloon?
Balloon, yes.
How do you want to apply that? How do you want to apply that?
The soap bubble itself.
It's not soap bubble. Okay, fine. Soap bubbles,
So they'll have minimum potential energy, surface area of it is minimum.
Correct. Okay.
So won't B try to reduce its surface area?
See, now the other thing is, what is the mechanism for the transportation of, whatever physical quantity from one point to another point? That also has to be taken into consideration. So here you see the air will go from a region of higher pressure to lower pressure. Isn't it? The mechanism is that now? Okay, it will go from this to this. So therefore, that is what is going to happen here. So since the pressure here in A and C is more, okay, so therefore, it is pushing it towards B. Got it? Okay. Anyways, see students, you should enjoy learning this theory properly. It's very, very interesting. Then solving these problems is real fun, and you will remember it forever. But if you have some discrete knowledge here and there, that information, this information, and if you try to use that and try to solve the problem, you are not learning anything, and it is not going to help you in any way. Because any other problem given to you, you will always be having some question mark, what to do, and you will start doing some guesswork. You are not going to do well in the exams. So just enjoy learning science, and you will definitely do